Next, I want to talk about some option analytics, but I'm not going to talk about the Black-Scholes formula. A lot of the option analytics, a lot of the point is to calculate what the premium on an option should be. How much should you charge for a call option or a put option? And Fisher Black and Myron Scholes developed a formula for pricing options. But that formula applies best when the options can be exercised at no cost. And what we'll see is that the embedded options in a mortgage tend to be costly to exercise, and so for that reason we don't use Black-Scholes. We use other means, and I'll get into those. I'm not going to get into those today. Today I just want to talk about basic option analytics. And the first thing I want to talk about is something called put-call parity. And that goes as follows. You know that if you have let's talk about at-the-money options. That'll make it easiest. So that means that if the stock price is $100, then the options have a strike price of $100. And so if we're in that kind of environment, then if you have a call option, you have all the upside and none of the downside. And if you write a put option, that is, you're short the put option, you would have all the downside and none of the upside. That is, if the stock goes down, the person to whom you've sold the put option is going to profit at your expense, whereas if the stock doesn't go down, then they won't. So what that gives rise to is the notion, since the call option has all the upside and the put option, when you write a put option you have all the downside of owning a stock, then that means that if you've bought a call and sold a put, that's like having the stock. So we write S, you can do this as sort of an algebra, S is equal to C minus P. That means that the value of the stock is equal to the call option value minus the put option value, again using an at-the-money sort of option. So to put this another way, if I have bought a call option and sold a put option, then I should get the same result as if I'd taken a levered position in the stock. That is, if I'd borrowed money to buy the stock. So there's a sense in which options create a leverage opportunity. And we can work with this put-call parity using regular algebra. So I could take the negative sign of this, negative S is equal to, and then I'll reverse this, P minus C. So what that says is if I own a put option and sell a call option, that's equivalent to shorting the stock. So I've kind of created a synthetic short position in the stock, and that might be easier to create a short position that way than to actually try to short the stock in the market. Just to do more algebra, let's add the P to both sides. So that gives us S plus P equals C. So that says owning the stock and owning a put option is the same as owning a call option. That is, we know with a call option you get unlimited upside, and you can only lose the option premium. Similarly, if I buy the stock and also have a put option to sell it at the current price, then I have again unlimited upside, but I forfeit the option premium. That's my maximum downside. So that's some simple analytics with put-call parity.